Hello and welcome. I'm Tyler Baker, Chief Technology Officer at Foundries.io, and today we're going to talk about managing boot firmware updates securely over the air. Let's jump right into it. So, it's a lot harder than it seems, so we need to define what the end goal of boot firmware updates are. I like to look at it from a set of product requirements. If we're building an IoT project or an edge product or an embedded product, what are we needing to go to market? Well, I think most of us would agree these days secure boot flow is pretty much required. Uh, Ideally, when you're giving a payload to this device, it can verify its authenticity. And when that payload is updated, you are able to roll back. So, some sort of a watchdog integration there. And then you have tools available to you in user space for setting boot variables to tell the bootloaders themselves that there's an update that's pending and that they need to flash it. Now, integration with the traditional boot manager, those will come up a lot. Some of us building products can't use Grub due to license reasons and performance reasons. We need to be able to work without a traditional boot manager in the way, and that's a product requirement, unfortunately. So the other part of this is we need to be able to update absolutely every other piece of firmware that is present on the device. So if you're running SPL, if you're running ATF, OptE, and any bootloader that you may have after that, that all needs to be updated. And ideally, this is all built on standards. So how are we going to get there? Well, we should probably talk about what solutions exist today. So let's look at ARM System Ready IR. And if you're not familiar with ARM System Ready IR, it's a band of system certification. So it's a set of these four different components that makes you compliant to System Ready IR. So the first one is ARM-based system architecture. Second one is embedded base boot requirements, EBBR. This will come up a lot. And then a specific recipe of EBBR in the ARM-based boot requirement specification. And of course device tree. So those kind of things will get you into this realm of system ready IR. So let's talk a little bit more about the specific feature within EBBR that's interesting to us. So that's EFI capsule updates. This is being able to create a capsule that will contain all your boot firmware and allow you to update it over the air or through a manual intervention of some sort. So U-boot implements this UEFI layer that follows the EBBR specification. It does require 2021-04 or newer versions of U-boot, so it's fairly new, and it provides these DFU interfaces to allow you to set variables to tell U-boot where to write firmware. It also tells you, where to actually perform the update. So all of this exists, and this framework is now in U-boot, which is great. One thing about EBR I just want to point out does not yet enforce security. I believe support for capsule verification has been added recently, but it's not actively enforced, so it's the step in the right direction. It does require the use of EFI boot variables. If you're not familiar with those, they're variables that EFI typically uses and requires to be set in order to boot a platform. And it doesn't work without a traditional boot manager at this time. So there's also currently no way to roll back a capsule update without a custom implementation, which you'd have to provide. So um, let's talk about actually building one of these things. So what do you need to create a capsule update? Well, you got to build your firmware first. That's the first step. So SPL, if you require that, ATE, OptE, and your U-boot, in this case, is this I'm going to use as an example. And then you're going to create a data structure like this device tree definition here, which is an image source definition that basically says this piece of firmware does this. This is its name, there's its architecture, where do you want me to load it, all of those fun things you get to describe in this image source file. And then you take that image source file, and then you're going to make your image source blob from it. So you're going to use this first command here, and these tools are all now in the U-boot sources, by the way, so you can just, if you're already checked out the right version of U-boot, these are available to you. So you use make image, and you pass it in your image source definition, and you'll get out an image source blob, this capsule 1 ITB. And then you're going to build that actual capsule update. So you can take your ITB and you can use make EFI capsule, and then you're going to produce a capsule1.bin. In this example, you can name it anything you want, but this is just for example purposes. And so now you've created a firmware update capsule that will be able to be put onto the device and have that bootloader flash itself. So now the problem is, how do you get it on the device? Well, typically you would use an OTA solution, but for the easy use, if you want to try this out, I mean, you can just copy the capsule somewhere where the boot firmware can read it. Now, how do you update it? There's a couple different ways. There's actually three different ways here. So you could just run shell commands, like that's the first example. You basically tell it where it needs to load the Capsule 1 bin that you created, and then you set a boot flag saying, next boot, go ahead and update it. The second way is you can use EFI debug directly to basically load it and update it all in one. And then you can also place the firmware under slash EFI capsule update. Uh, you basically do need to kind of have it loaded and stuff like that. But here's an example of how you might actually load it from a file system and then set some variables and actually call the disk update. So a couple different options for you to do. Obviously, this would all need to be automated in some sort of a production system, but you get the gist. Now you got to reboot the target. So before the board jumps into grub, the firmware is going to be updated. So after the update, the capsule binary is going to be removed. You will need to reboot again for the new firmware to be loaded. So you do have to do 2 reboots in order to get this new firmware to load. After the second reboot, you can check for new versions of the firmware and verify its expected version, or if you've added functionality into the update, you can check that functionality is then present in the current bootloader that's running. So it's pretty simple to do, um, and that's great. So what can we take away from this learning? Well, there are gaps to be filled to use this in a product, right? And I'm just going to list a few here. We're going to kind of talk about that real quick. So the creation of firmware updates are very much target specific. You're not going to get away from that. You do need some way to securely deploy these capsule binaries to the devices for scaling. Multiple reboots is not optimal, but it is functional. Ideally, we would really have a way to do this without a traditional boot manager. It's just extra bloat that goes into the image, and there's licensing issues, and there's a whole bunch of reasons why traditional boot managers may not be a great fit for everyone. And there's currently no way to roll back. So if you you give a bad capsule update right now, you're gonna have to reflash, which isn't a great situation to be in. So let's look at how it aligns with our product requirements. So secure boot flow is not enforced, and so there's no fit verification. So if you sign fit images for your product, Grub can't verify them. So that's a missing piece there. Firmware payload verification, there is support for that, however, not required by EBVR. So I'm going to give it a pass here. Rollback capabilities, you could implement this yourself, but currently that is not provided for you. And then user space integration with setting the EFI boot variables, they've got that. But however, again, traditional boot manager, no go there. It is able to update all the different firmware that you require, and it is built on standards. So this is a really good solution, and we're really looking forward to kind of filling these gaps in and getting this in shape to run on products. But it's not, right? So how do we ship products today? You're probably asking yourself that question. Like, this is great. I want something generic, especially for the boot firmware on ARM devices. It would solve a lot of problems, absolutely. But we need an interim solution today that is product ready, that ideally provides OTA solution for the firmware. It probably will be SoC specific for now. But I think the important part is it's going to lay a path forward. And I'll get into that next slide about what that actually means. And while we're at it, we should get rid of that traditional boot manager if we can, and so we can choose what we want to use for the boot manager. So let's talk about the path forward. How are we going to fill the gaps to go to market now? So obviously, providing an OTA solution, being able to roll back the payloads in case there's a problem, um, and setting all of this up without a use of a traditional boot manager. The idea is that then we can get to a spot where we can use eBBR and system ready out of the box, but we're not there yet. So quickly, I just want to highlight kind of what we're doing at Foundries, how we're solving this problem. We're using AB firmware slots. We're able to update SPL, ATF, OptE, and U-boot payloads, and it maintains the root of trust through the update lifecycle. So we can update secure devices that are fused, and we can roll back those updates if needed. So we've kind of laid this out on a couple different SoCs and have some documentation around how we actually do it. And I'm going to actually show you a demo here in a little bit on how easy this is and how easy our system makes this. So the real takeaway from this slide is that we've got a way to update all the firmware on the device that is product ready. So as system ready IR and eBBR evolve into those those requirements that we need, we can update to them. We can take customers today and move them along and get them into compliance in the future, but we don't have to wait around for that. So again, we want to move towards system ready, right? As the gaps are filled, we want to be able to get there. We have a solution in place to do that. So, really the takeaway here is if you need to ship a product today, there's a way forward with the promise of system ready tomorrow. So you can get that compliance that you want. You can get all of this nice generic firmware parts, but if you need to ship today, there are solutions out there. So do you want to try this yourself? That is the question. I'm going to be hosting a webinar in November, and we'll be providing Arduino Pro Linux boards to attendees. They're IMX8 based. They have a secure element on it. They're a really neat piece of gear. Um, Space is limited, so my email address is down here. If you want to get in on this and actually try some of the stuff that you're seeing right now, please get in contact with me. They are, kind of limited seats, so the earlier the better. And then, we'll get you some information and figure out how to get you free hardware where you can actually try this out yourself. So, I just wanted to throw that out there. Is there any questions? All right, so let's get to the firmware update demo. I'm going to jump out of the slides here and kind of show my desktop really quick. Let's jump here. Okay, let's quickly go over the hardware setup here. So on the right lower corner, we have the IMX8M Mini EVK from NXP, and then connected to it over I2C, we have the SE050 secure element. This is going to actually have a hardware security element that is chaining the root of trust for secure boot and for our update agent. When we push the update over the air, it's going to be cryptographically validated by this hardware security element, and as well as all the keys on this device are going to be stored inside of that element. So I just wanted to point that out. It's kind of a neat setup here. On the top, you're going to see the UART for this device. It's currently powered off. I'm going to kind of walk you through what we're going to see here. So before we get into the demo, just to save time, since I don't have a whole lot of time to do this demo, I've already pushed the patch and created the update, but I'll kind of walk you through that right now. So the way this works is with Foundries, you get a factory. Inside of a factory, you create targets. Targets are references to incremental platform updates and application containers. And within that platform update, you have your boot firmware. So the idea would be you'd create a patch to add something, either it's a new version of U-boot, to patch U-boot, to add configuration like we're going to show today. You push that to your factory, a new target would be created, and your device would update to it. And that's kind of how it works. So you can see I've registered a device here. It's the IMX8MM that we have displayed on camera. And if you click on it, you get a little bit of information about what updates it's taken, what its network configuration is, all of that fun stuff. So we have a device management platform kind of sitting on top of this system. So what am I going to change? What is the patch that I'm going to push? So I'm going to enable some U-boot configurations to provide a USB command in U-boot from the shell. Now, if you know about U-boot, when you change configuration like this, you actually have to recompile a new version of U-boot and load it onto the device for you to be able to have those commands. So we're going to automate all of that. I've already pushed this patch. I've already created the update. The device is going to, as soon as it boots up and talks to the servers, it's going to do the update. And we're going to watch this process. So I'm going to show you before we do the update that we actually don't have this USB command. And then after the update happens, which you're going to see here in a moment, that we do have the USB command. So that is the gist of it. So when I pushed this patch, what happened? Target was created. You can kind of see here, I believe, which version this device is on. So it's on 27 right now. Which is here. We've pushed 29, which is the latest target, and it is the enable U-boot USB command. And so we're building for IMX6, IMX8M, and IMX8MQ EVK as well. So we can do multiple platform and application builds within a factory. So now that we've pushed it, let's go ahead and turn this device on and actually see this firmware update in action. So again, UART console on the top here. I'm going to throw the power button. We're going to verify the hashes. The SE050 is up. We're going to break the U-boot console here, and we're going to type USB in. And it's going to tell us there's an unknown command, USB, try for help. So we don't have that command support in this current version of U-boot that is booted. So now we're going to boot it up to the distribution. Our actualizer client is going to do the over-the-air update, and when it reboots, it's going to reflash U-boot, and it's going to come back up, and hopefully we have the USB command. So let's give it a shot right now. So we're going to run boot command, and we are loading the user space up. I'll SSH in just so we can see if we can catch the OTA process. It's quite fast, so we might not be able to get it, but we'll see. And the SC050 is working. There it goes. Let's see if we can grab this last bit of it here. Oh, there we go. Okay, so it's found a new target 29. It's receiving the objects over OS tree. Again, you can see actually the elliptic curve sign operations that are happening on the SE050. So every time it's interacting with the backend, it's actually validating signatures here as well. So the update has happened. So we're going to let this check everything over. It's going to reflash that version of U-boot here in just a second. I'll let it go. Yep, there it goes. Now it's updated U-boot, and this is the second time around. I'm going to actually stop it here and type in USB. And now you can see that we have this new USB command here now. So that is kind of an example of how an over-the-air update firmware kind of is a product-ready solution where you can securely update it. You can have rollback. There's 2 copies of this being stored. You have an OTA system that's integrated, and you're able to deliver patches very quickly. So I'll tell you what, we'll let this thing, now that you see that, we'll run the boot command, we'll boot it back up, and it'll actually log in and say that the update was complete once it hits user space. Now, again, you typically wouldn't break the U-boot console, on a production device like this and show it. You would have it automatically boot. But just, in terms of doing this demo, I think this kind of highlights how easy it is to simply push a patch, create a new target, and send the update down to the device and have new firmware loaded. So it really can be that simple. And the great thing is, as I kind of talked about EBBR and system ready IR, those are configs, right, in U-boot that need to be enabled. And so as EBBR moves to kind of, more of a production ready type specification, we can migrate away from this particular solution to, system ready IR and EBBR, but we're able to ship product now. So that's kind of our plan at Foundries, is to be compliant, and then as those kind of product features get filled in and those gaps start to, work upstream, then we're going to slowly migrate our customers and our factories over to using a pure EVBR system ready IR implementation. So that's the demo. If you have any questions, please reach out. Again, we're doing a webinar. If you want free hardware, we're going to be doing some Arduino Pro Linux boards. We're going to be giving that away. Go ahead and check the last slide in this presentation. It's got some info to get in contact with me. We'll get you signed up. Seats are limited, so that's probably going to happen sometime in November, and you can try all this out yourself with a real board that we'll send to you. So I thank you for your time. Hopefully you enjoyed the demo and in the presentation. Thank you very much.